Welcome to Bald Guy DIY. In this video, I'm completing the 3D printer enclosure that I've been working on the last couple videos, and this time I'm hacking up the power supply on my 3D printer in order to supply power to the 5-volt Raspberry Pi and the 12-volt LED lighting. The power supply on my 3D printer is a 24-volt DC supply, which is great for the printer itself, but when it comes to the Octopi server and the 12-volt LED lighting, that's not going to be very helpful. In this video, I'm going to add a 5-volt regulator that I bought on Amazon, as well as a 12-volt regulator that I made with components. Check it out as I do the hack and then also wire everything up, so in the end I have a finished enclosure ready for the printer.
So the first thing we need to do is open up the power supply itself. Now it does come with a warning label saying that this is a shock hazard, and as you'll see when we get it open, we're not actually going to stick our fingers or any kind of instrument anywhere near any capacitors or anything else. You can see inside here, it's just a self-contained box inside the enclosure, and really we're just going to stay on the outside of this and loosen up the screws that actually contain the terminals. So of course I'm paying attention to what wires go where so that I can put it back the way that it was. I'm simply going to be removing it so I have access to it and creating my own little regulator that's going to go in place. Now this is a little bit of an intermediate soldering project. I'm going to show you how I use the LM350 regulator and the circuit that I use, but basically I just solder the jumper wires that I'm going to need and then begin to attach the components. There's a 10 kilo ohm trim pot that's used, as well as a 560 ohm resistor. That provides us the voltage that we need to dial in with the voltage regulator to give us the exact voltage that we want. If you're interested, here's the connection diagram for the LM350 voltage regulator, where you choose the values for R1 and R2, the two resistors that you're going to use, connect them up. In this case, you use R2 as a variable resistor or trim potentiometer, and then I used a 560 ohm resistor for R1, and then by fine-tuning the trim pot, you'll be able to get the voltage that you want on the output. I also put a capacitor across the V-out terminals in order to smooth the signal and hopefully reduce the amount of flicker that I get on my own enclosure. The 5-volt regulator I chose to use, instead of building my own, which I had tried in the past, is to use one that I found on Amazon. It's a little hobby power supply for remote controlled things, and what it's used for is providing a nice consistent 5-volt supply, which the Raspberry Pi requires. Anything that's unstable, the Raspberry Pi just won't handle. With my wiring complete, and I'm missing a little bit of footage, but with my wiring complete here, I can start to put it back together. I'm just going to connect all the terminals, and I'm going to include the positive terminal on my little printed circuit board and the 5-volt power supply to the positive terminal and the negative terminal from my prototype board to the negative terminal. Using double-sided stickers to stick it down, tuck in the 5-volt supply, and put it back together. Next up, I'm going to shorten up a couple of cables that have 90-degree connectors on them so that I can do much better cable management. Where I'm going to mount my Raspberry Pi really is right next to the connector for the MakerGear M2 printer that I have, and 6 feet of cord just seems like a lot of waste. So here I'm shortening 2 USB cables, just stripping the leads. There's 2 leads that are for power and 2 leads that are for data, and we're going to need all 4 of those on this one. So I'm just going to strip all the leads and solder them together. Because it's such a short distance, I'm not concerned about connecting the shields. If it was going to be something a little longer, I would have. The shield is just that jacket that surrounds the lead. Now that I have it finished, I'm going to just check the connection there by giving it a tug and then trimming off any little extra bits. Now I'm just going to use electrical tape here. You could use sleeving, which would be maybe a little more aesthetically pleasing, but in this case I 3D printed a sleeve that I'm going to insert over top of it all in order to get a little more finished look. I like using 3D printed parts around a 3D printer. I think it just makes the whole experience a little more authentic. Because it's such low voltage, I'm simply going to do a full wrap around one lead and then join it with the companion lead right next to it. At 5 volts, you really don't need much insulation in between each component. Now it's time to cover it up with the sleeve. Now I did use a pen here because when I printed out this sleeve, I did get quite a tight fit. So I simply just shoved a pen through the sleeve in order to loosen it up a little bit, and then once it was loosened up, I could slide it back in place and everything fit properly. You can see once I have it done and I have the Raspberry Pi mounted in place, how great it looks. Low profile, held in place with double-sided Velcro, and how nice and short that little piece of cable is now. The last thing we need to do is add the enclosure lighting. Here I found some RGB LED strips, and I'm simply going to connect those together to give myself a nice horseshoe around the inside of the enclosure. These are actually RGB LEDs, which could be used to control the color temperature or give yourself a variety of colors. I'm not going to use it that way at this point. Right now I just want a nice white, so I'm going to supply the same voltage to all 3 different colored LEDs so that I get a nice white color instead. I just simply tin each of the leads and then I go through and connect them to the terminals. There's 4 terminals, a 12-volt terminal, and one for each red, green, and blue LED. And I'm simply going to splice the red, green, and blue leads together, and I'm going to supply the plus 12 volts, which is called common anode, to the red wire on a USB cable, and I'm going to connect the black wire to the 3 red, green, blue, and that's going to provide me what I need. Now I did use a USB cable that I hacked in order to do this, but I did it backwards so that someone couldn't unintentionally connect a 5-volt USB device to it. If you connected a 5-volt USB device to a 12-volt power supply, you are going to have some problems. So take note, you don't want to be able to do that. Now here I'm just going to use tape to lay out exactly where I want the lighting to be. It's a good idea to get a good frame of reference. You could of course draw lines or something to follow. And then I use some 3D printed clips to hold it down. My video didn't cooperate very well, so I'll just show you what it looked like when I got all the clips in place. Pretty straightforward, held in place. I also used some 3D printed brackets to mount the power supply underneath one of the tables in order to make it nice and accessible, but also out of the way. Here's a final look of the enclosure ready to go.
Now we've completed all 3 parts of our 3D printer enclosure. It's ready to add a printer and start printing. This one's actually heading off to my brother-in-law's place. Tim, I'm sorry this has taken so long to get done, but it's finally ready. I hope you enjoyed as much as I've enjoyed mine. For those of you watching, if you enjoy our videos, please subscribe, ring the bell to be notified of future videos. Let us know in the comments what you'd like to see next. Ideas to improve the channel, anything like that. And feel free to share with as many creative people in your life. And in all your DIY projects, don't be afraid to be bolder.